Number one, as you can see, this piecewise function has two parts. Together they make one function. I'm going to color them two different colors just so you can kind of keep those two separate in your head. They have to share the coordinate plane, or more specifically, they have to share the x-axis. On some parts, we're going to use the red function, and on some parts, we're going to use the blue. The function itself tells us when to use each function. So for all the x's that are greater than or equal to 1, we're going to use the red function. For all the x's that are less than 1, we're going to use the blue one. Let's map the red one first. The most important point is at the end of this piece, which happens right here, where x is greater than or at 1, essentially. Okay, because the red one includes 1, where x equals 1, we're going to have to put a closed circle there. So x equals 1, what is the y? We find it by plugging it in right here. 2 times 1 plus 2, that's 3. So at x is 1, y is 3, closed circle. Now, this is a line. If I plot one more point, I'll be done with that side. I'm going to have to do it for another x that's greater than 1. Why not do it for 3? So if x is 3, what's y? Well, let's plug it in. 2 times 3 is 6, plus 1 is 7. So at 3, 7, I'm drawing another closed circle, well within the boundaries. Okay, and it should look something like that. The other part of the function, it's x squared. That's quadratic. We know the graph is going to be a parabola, so we probably have to plot more than just 2 points. In any case, the first point we're going to plot happens at 1. Now, since this guy does not include x equals 1, that's the red guys, we're going to have to put an open circle there. Well, if x is 1, what is y? We plug it in. 1 squared plus 3 is 4. So 1, 4, I'm putting an open circle. This is for the left side. We need to plot a few more points. How about 0? 0 squared plus 3 is 3. I'm putting a closed circle here because this is well within the bounds. It's completely less than 1. Negative 1 squared plus 3 is 4. And now negative 2. Negative 2 squared is 4 plus 3 is 7. Okay, I hope you can see the shape forming here. This is a parabola, as we expected. And that's what the graph looks like. Is this a function? Well, it passes the vertical line test, so the answer is yes. They want to know f of negative 2. There's two ways to find this. I can look on the graph, negative 2, y is 7. Or I can use the algebraically. I can use this rule here. Negative 2 is less than 1, so I'm going to plug it in right here. Again, we get 7. What about 6? I can look at the graph, but 6 isn't on here. Let's go over here. Because 6 is greater than 1, I'm going to use the red. If I plug it in, 2 times 6 is 12, plus 1 is 13. And then f of 1. I can look at the graph. 1, I have a closed dot at 3, so there it is. If I didn't graph it, because it's included here, I'm going to plug 1 into this function, and there it goes. Our second function is, again, 2 pieces. In this case, they're both lines, so this should actually be easier than the first one. I'm going to start with the red one. The end of the line happens at 2. Because of this equal here, I'm going to do a closed circle. It's included. Well, when x is 2, what's y? Plug it in. Negative 2 times 2 is negative 4, plus 1 is negative 3. So 2, negative 3, closed circle. I'm going to plot one more point, and I just need to pick one more point for x less than 2. The easiest math is if I pick x equals 0, which is less than 2. If x is 0, what's y? I'm just going to plug it in, and I get 1. So 0, 1 is the second point, and I'm just going to connect the dots over here. Probably didn't draw a perfect straight line, but again, it's good enough. Okay, and now for the second point. Again, the most important point is the end of the line. It's also going to be at 2, but this time I'm going to have to put an open circle. If x is 2, what's y? 10 minus 4 is 6. So 2, 6. And now I need another point. This is a line, just one more point will do. I'm going to plug in 4. Actually, that's too high. Let me plug in 3. If x is 3, what's y? I'm going to plug it in. That's 15 minus 4, which is 11. It's quite high. 3, and then go up 11. 9, it's off the screen. I'm going to put it at the edge of the screen for you, and then we're going to connect the dots. Our graph should look something like that. Okay, is this a function? It passes the vertical line test, so I vote yes. All right, f of negative 4. That's kind of off of our screen. We didn't graph that. Since x is less than 2, we're going to plug it in here. Negative 4 times negative 2, 8 plus 1 is 9. For 8, again, it's off the screen. It's not on our graph. I'm going to put it here because 8 is greater than 2. Plug it in. It's going to be 40 minus 4, which is 36. F of 2. Well, I've got it right here. 2, negative 3. I can see it on the graph. Or I'd plug it in to the top function since 2 is equal to 2. And I'd get negative 3. Number 3. This one's 3 parts. And it includes a quadratic, so this one's kind of ugly. All right, we'll start with the top one here. I'm going to have to plot several points because it's quadratic. The first point, most important point, is the end. That happens where x equals 0. Because if this is equal, 0 is included, I'm going to do a closed circle. Well, if x is 0, I have to find y. Plug it in. Negative 1. 0, negative 1, closed circle. And now x is less than 0, so I'm going to have a parabola in the left side. Let's plot more points. We'll plot negative 1. Negative 1 squared minus 1 is 0. Negative 2, that's going to be 3. Negative 3 squared is 9 minus 1 is 8. So negative 3, 8. All right, now we've run out of room there, but we do see that the shape we have is part of a parabola. And now we're going to move on to the second part. Okay, this is a line, and it has 2 endpoints instead of just 1. So we're going to plot those 2 and then just connect them. First, we'll start with 0. Because 0 is not included, we'll have to put an open circle. If x is 0, what's y? Plug it in. 0 minus 1, negative 1. Now, this one's interesting because it's the same point as the closed circle before. I'm going to put an open circle around that closed circle. And then the other endpoint happens when x equals 5 and it's included, so I'm putting a closed circle. X is 5, plug it in to find the y. 2 times 5 minus 1 is 9. So 5, and then go up 9. It's right here. I'm going to connect these dots. Okay, that's not very straight, but it works. I want to point out that this is still a function, open circle, closed circle, no big deal. The only difference here is that this function is continuous, whereas the last time we had a discontinuity. Okay, and then finally, this one, which is super easy. The endpoint that we have is it happens at 5. We don't get to include it, so we use an open circle, and y is 3. X is 5, y is 3, open circle. If you'd like, this is a line. We can plot one more point, but it's a horizontal line, so it's pretty obvious. But let's say x is 7, then y is going to be 3. 7 and 3 is right here. And connect the dots, go forever to the right. Those are the 3 parts. Is it a function? Yes, it passes the vertical line test. F of negative 2. Let me stop real quick. Is this a function or not? Some relations, some piecewise relations, might not be functions. Typically they will be, but let's say these parts right here overlap. If they overlap, then you would have a piecewise relation that wasn't a piecewise function. Okay, negative 2. I can't just go straight to the graph. Negative 2, 3. If I were to evaluate this algebraically, I'd find which one of these guys includes negative 2. It's going to be here because negative 2 is less than 0. And if you want to know the function value, you plug it in here. 4 minus 1 is 3. Okay, f of 0. Again, I can look at the graph. Clearly, it's negative 1. If I were to evaluate it algebraically, because 0 is included in the red part of the piecewise function, I would plug it in here, again, by negative 1. F of 5. 5. The closed dot is at 9. The closed circle is at 9, so I know the answer is 9. Well, again, I can find it out using this part of the function. It includes 5. Plug it in and get 9. Finally, number 4. Again, just 2 parts for this one. This might be the easiest one of all. Okay, first I'm going to graph the red part here, the endpoint being the most important point. I'm going to go do it first. Because it's included, I'm doing a closed circle. If x is -3, y is 5. -3, +5, closed circle. And again, this is x is less than -3, so I need to pick a point over here. Why not -5? Okay, if x is -5, which is less than -3, x is -5, y is 5. Closed circle, and we're going that way. This one's pretty obvious. It's a horizontal line. You don't really have to plot that second point if it's so obvious. And then we're going to graph the second part. Again, we're going to go to the endpoint first. It's at -3. We're going to need an open circle. If x is -3, plug it in and find that y is +3. Open circle. Okay, this is a line. I need to plot one more point, and I can connect them. The easiest math would be if x is 0, which is greater than -3, so I know to use this one. X is 0, y is -3. 0, -3. And this time, again, a closed dot because I'm well within the boundaries for this one. Okay, so we've plotted both parts, both pieces. Is this a function? It passes the vertical line test. F of -4, it's clearly 5. We can see it graphically, or we could just use this definition. That's part of the function. F of 0, I've already plotted that. It's -3, but if I wasn't sure, I could plug it in here. And then finally, f of +3. It's off my graph. Can't figure it out that way. Which function do I use? Well, 3 is greater than -3, so I plug it into the bottom one. 2 times -3 is -6 minus 3 is -9.